would be. Okay, guys, so we're actually going over the homework as part of today's because we're hitting a piece we didn't talk too much about in class. And it's this whole piece on the fractional edge length. Our key here, because I have no overlaps or gaps, I need to figure out what size fractional cube will fit perfectly in all three dimensions. So if you go to the back side, they actually give a really good example for this type of a problem. Because my mixed numbers all have different denominators. Okay? So because I have a 1/2, a 1/5, and a 3/10, in order to figure out what would go to all three, I need to find the LCD, least common denominator, also known as the least common multiple. So I can use my denominators, 2, 5, and 10. We can use the cake method to figure out what my LCD is. So I would start out, what will go into all three of them? Nothing, meaning they are relatively prime. But remember, when I have three numbers, we do the false ceiling, right? Glass ceiling. So I still have 2, 5, and 10. Can I divide any two of those numbers by the same number? Yes, what, Storm? 2 and 10, I can divide both those by 2. Gives me a 1, a 5, and a 5. Are there any two of those numbers I can divide by the same? Yes, 5. So I do that. And then 1, 1, 1. All ones across the top. So that makes it nice, because that means when I multiply all of them for the LCM, it's just 10. Meaning, the dimensional cube I could use is a 1/10. Okay? So it means if I'm going this way, 1/10, I'd use 5 of them. Going up, I would do 2 of them to get 1/5. Going across, I would use 3 of them. So technically, 4/10 would be 40 of them plus the 2 extras. So I'd do 42 cubes to the top. Going across, I would need 90 plus the 3 would be 93 cubes across the top bottom. And then going across the back, the 1/2 is actually 5 cubes. So I would need 10, 15 cubes going back. 25, sorry. That's a 2. Make sense? But that now it would be perfectly packed in all three directions with no overlaps. We'd have that whole space filled. If I tried using a 1/2, I'd end up with gaps because I can't get the 1/5 to come out exactly to a 1/2, can I? If I use the 1/5 cube, also would work for the 1/2 because I get it 2/5 or 3/5 are my options. So 2/5 would be as close as I could get in that dimension. I'd have a gap there. Does that make sense for everybody? I'll be honest, you're not going to see this kind of question about the dimensions on any test from Mr. Chan and I. Where you're likely to see this is on the mandatory test that we're forced to give, because at Dadia, they really love these questions, because you're basically testing like 4 concepts in one when I make you do fractional cubes. Was everybody clear on that? Okay, let's go back to the first page and start grading. And I'm going to pause the video now because that was the most important part we wanted.
Alright guys, if you look at the bottom of page 99, we are starting with a review of what we just went over in our morning minute. You are finding the area of a composite figure. So I'm going to give you about 2 minutes to do this, and then we will go over it as exactly what we just did. Alright, go, 2 minutes. Alright, 5, 4, 3. There are several ways you can solve this. You can decompose in many different ways, or you can compose and find the area. I am going to separate it this way. No matter how you did it, you should still get the same answer. Okay? So we have, again, 3 rectangles. And what do we know about one or more of our rectangles? 2 of them are equal. 1 and 3 are the same. Yes? So what is my length for rectangle 1?
2 by
10. And what is my width for rectangle 1?
2.
So that gives me 20 yards squared. So that means 3 is the same. You should be writing this if you don't have it on your paper. Then we have rectangle 2. And again, it is area equals length times width. So what is the length of rectangle 2? 6. Because if this part is 4, I need 6 more to make a total of 10. Yes? Yeah. And what is the width of rectangle 2? 2. Because if this is 2 and this is 2, I need 2 there to make a total of 6. Yes? So I get 12. Am I done? No, it's asking for the total area, so I need to add them together, and I get 52 yards squared. Any questions? All right, guys, we are going into surface area today. So it is basically area with several steps. So let's turn to the next page. All right, so I said you needed a highlighter, and we are going to highlight the definition for a net. A net is a two-dimensional representation of a three-dimensional figure. It means that it's flat, and if you fold it and tape it, it will make a three-dimensional figure or a geometric solid. Does that make sense? So, if you look at number 2, we're going to skip number 1. These are nets that we want you to look at and determine which ones would you fold and make into a cube. Which ones of these would make a cube? So let's talk about cubes for a second. What do we know about cubes? They have 6 sides. What else? All the sides are the same. They are all squares. So you are making a cube. So you're imagining folding these nets and taping it together into a three-dimensional cube. Which ones of these would make that cube? I'm going to give you about 3 minutes. Do not talk about it with your neighbor. This is for you to figure out. When you are done, if your neighbor is done, then you can compare answers. Got it? All right, go for it.
Okay, so we circled the 11 for you. There were a couple of key things. How many sides does a cube have? 6. So I automatically know stuff like if it has 5 or it has 7, those can't be it, right? Okay? I also know when I fold it over, I need to fold it so that every side gets covered. So if I have 3 of them that are all together like this, there's no way to fold this that one's actually going to get used. So stuff like that's not going to work. I also need to have one going at least to each side. You may have noticed. So this one is kind of the most interesting of any of them when you really think about it, because when I fold it over and over, that third one ends up coming the other way. Same thing here, over and over, the other one ends up coming the other way. So you got to kind of mentally manipulate those to figure out how those are happening. Lucas, question? Yeah. Okay, good. So you're saying your previous experience has made it easier for you. No, Yanni? Gigi, please stop. It is crazy. Can't be to be talking while I'm talking. That's not good. Okay, so our big one. Did anybody else use another one? Lucas says, he said, use experience. From paper cutting. What other techniques did you guys use? Yes. Visualization. That's actually one, to me, one of the biggest ones. You can use visualization and mentally fold it up. You can actually see where each of the pieces is going. Lean in your chair. So what do all the nets for a cube have in common? They all have 6 sides.
Each side is the same.
Okay. Every box is the same size. Anything else? When I fold them all up, how many vertices are they going to have? 6. Okay? And how many edges do all of them have?
6.
Ooh, I think I got some people on this one.
4. Wait.
How many edges are they all going to have?
8.
12. Each of the side squares is going to have 4, right? And then that center is also going to have 4. So they all have 12 edges. Yes. Oh, you're right. There are 8 vertices. Thank you. Testing you guys. Nah. Okay, let's go to our next page. We're on 101. Okay, guys, we do need our highlighters again. Guys, quiet down. So, today is our primary focus is on what we call surface area. For surface area, it is the total area of all its 2-dimensional faces. You can also think about it as the total area covered by the net of the solid. So, with today's lesson, you're going to see a lot of focus on these nets because it's going to help lay out the entire shape for us to figure out what the surface area is. So how is the area of a face of a cube measured? Analyze the 2 responses and explain why the teacher is incorrect in her reasoning. So they actually gave it, how is the area of the face measured? Analyze the 2 responses. So the teacher says it's a 3D figure, which means that it's measured in cubic units. Isaiah says surface area is still a measuring area, which is always measured in square units. I told you Letitia is wrong. Why is she wrong? Is it not a 3-dimensional figure? It is. It is a 3-dimensional figure. Good. And that's the big key. Gigi, what does it use cubic units for? Maybe CJ can answer since he was just listening instead of talking. I just did ask you though. She literally just gave you the answer. They're even whispering it to you. Here's the big deal. Here's why there's a difference. This box would be a 3D figure. Okay? Volume is saying how many pencils can I stick inside of it. That's the volume. How much will go inside. Surface area is saying I need to wrap this up as a gift for Miss McShann because I'm really cheap and I want to give her something I didn't have to pay for. So how much wrapping paper would go on the outside? Does that make sense? The surface area. How much would I put to cover all those outside surfaces? Volume. Inside of it, how much does it hold? You have to have those two concepts completely separate because they are completely different. Why do you think I said it when she was gone?
A bottle of pixels.
Well, I can't have any secrets.
It's okay, I know your Wi-Fi's on, I guess it's fine.
That's true. Okay, so describe a strategy, guys. Listen up, please. Here's the biggest strategy. Make a net and treat it like a complex figure. So that's why we did the whole complex figure lesson before we did this. Because in order to find surface area, what you're going to do is you're going to put that away. That is not a tool, friends. That is a stool, something you sit on. Doesn't mean you had to play with it. You should have been writing this. You did write it, even though you're not even on the page we're on, friends. This is like the perfect one to write to the parents on. That's what I'm saying. Tell them where they're watching the video. Okay, consider the cube net shown. Calculate the surface area. Two big pieces here. It's a cube net. That tells me what? 6 sides, and they are all equal. Calculate the surface area. So here's what we're doing. So really all I got to do is figure out the surface area for 1 and multiply it by 6, right? So going through our base, area equals length times width. In this case, I know it's the same. So it's 2 inches times 2 inches, which is 4 square inches. And I know that all 6 of them are identical because it's a cube. So make that times 6 gives us 24 square inches. Make sense, guys? Okay. So, what is the surface area of a unit cube? There's our question. So, what do we know about a unit cube, guys? A unit cube. Which are what measurement? Vivian? 1. By definition, if it's a unit cube, it's a unit of 1. So that means, going back to our formula, so it's now 1 unit times 1 unit, which is 1 unit squared. How many sides are there on the unit cube?
Get the word cube.
6. So I multiply by 6 because there's 6 of those ones. So that means it's 6 unit cubes. So regardless of what the unit is, if it's a cube, it's going to be 6 times that unit. If it's a unit cube. And because it's area, it will always be squared, because area is always squared. Is there anything we've covered so far that you have not understood? Okay, guys, on page 102. 102. So we are skipping several problems, just so you know, because there's a lot more here than we can cover in one class period. So describe the dimensions of the faces of the net that are on opposite sides of the rectangular prism. So what would you say about the dimensions that are on opposite sides? In other words, I know that this side that I have folded out, so this would be the base of this rectangular prism. I know that this side is 3 centimeters, so what do I know about this side? Storm? Why? Because it's the same shape. It's the same rectangle, right? So I know that one is also 3 centimeters. If I know that this is 4 centimeters, what do I know about this? Why?
Because it's the same thing.
Because it's the same shape. Okay? If I know this is 4 centimeters, what do I know about this? Why? Same shape. Does that make sense, guys? If I know this is 6 centimeters, what do I know about this line? Why? Same shape. Because they are rectangles, the opposing sides are always identical. Does that make sense? So what we can say is, because they are all rectangles, opposing sides are equal. And everybody understands why. Anybody not understand why? Because you have to have this concept for what we're doing. So as we start moving into actually calculating the areas, okay, so we're going to change that to opposite sides. Because opposing is too different than opposite.
We're in 6th grade.
Okay? So calculate the surface area of the right rectangular prism. In other words, they've now given all of the dimensions that you need. I want you to find the area. And we're actually going to give you guys a couple minutes. We're going to let you do both number 6 and number 7. So we'll give you guys 5 minutes to knock those two out.
All right, we're going to go over number 6 quickly before I let you continue with number 7 because some of you are struggling. First off, this is exactly what we've been doing with complex figures. You are finding the area of each individual shape and then adding them together to get your total surface area. Make sense? Okay, so you have a net. 2D, yes? When you fold them, sides are going to meet in the corners. Okay? Does that make sense? So two that you don't think would actually touch do touch when you fold them up. Does that make sense?
Yes.
Does everybody see that?
Yes.
Okay, so let's look at this one. Let's talk about our middle rectangle. I'm going to erase all of these. Okay. Let's look at our middle rectangle. What is the length of our middle rectangle? 6. And what is the width of our middle rectangle? 3. So it is 18 centimeters squared. If you look, we have the exact same rectangle here. Yes? So that means we have 2 of those, which is 36 centimeters squared. Does that make sense?
Yes.
Okay, so let's go to rectangle 2. And we're going to make this rectangle 2. What is my length? 6. And what is my width? 4. So that is 24 centimeters squared. I have 2 of them because the top and the bottom and the front and the back of the rectangular prism are going to be the same. Remember, we talked about opposite sides are equal, yes? So there are 2 of them. So that is 48 centimeters squared. Then we have rectangle 3. What is the length of rectangle 3? Try this side, yes?
What does the V mean?
Where?
Under the 18. Just the dot.
Not when you write it vertically. Okay, what is the length of rectangle 3? Other side.
Now you say?
Is it 6? Looking at this one.
4.
It is 4. This is where that I just showed you comes in handy. I fold up one side and then I fold up that side and they match. Yes? So if this is 4, that means this is also 4 because they are equal. Any questions about that? What is the width of this rectangle? What? 3. So I get 12 centimeters squared. And there are 2 of them, so I get 24 centimeters squared. Do I know my surface area yet? No, I need to do what?
I'm sorry, CJ doesn't know what's happening, so he can't write anything down because he doesn't understand this.
Finding the
Even though
area
you're
of
literally
rectangle?
telling him what to do.
We're finding the areas of rectangles.
You're
We've
not
been finding the
writing
areas of
anything.
rectangles.
You're not listening. You're not writing anything down. Guys, if you don't listen, if you're not following along and writing this down, you will never understand. We literally can't do more than do all the work for you, which she is doing right now. And there's more than one person in this room that has nothing on their paper right now. You're right. You're not ever going to understand this when you won't listen and you won't work. And I'm done tired of it with this year. I don't know what it is with you guys.
Ooh, is this that class?
It was actually last class is my worst one. But 3 people in my side have not turned in a single homework assignment this year. Yeah, tell me about it.
So how do I find
3
it?
people have not turned in a single homework assignment. And yet they're confused and don't know what's going on.
In this class or in the whole?
No, in this class.
Alrighty, so how do I find the total surface area now that I know the areas of all my rectangles? So yep. Add them together. I have 24 plus 36 plus 48. 4 plus 6 is 10, plus 8 is 18. 3 plus 3 is 6, plus 4 is 10. So my total surface area is 108 centimeters squared. Why is it still centimeters squared? Area is always squared. Got it? All right, now that I've shown you how to do this one as an example, I'm going to give you 2 more minutes on number 7. Go for it. All right, guys, let's talk about this net. First of all, it looks just like this, yes? So when you fold it up, it's going to become a prism. Make sense? Okay. So it's going to look something like this when it's folded, right? Yes. Okay. So opposite sides are the same. So when I fold this, if this is my base, which one is going to be my top? The one that has 12 in it. This is my top. So these 2 are exactly the same. So I'm going to say 1 and 1. Got it? If I fold this one up, it's going to be my left side. So opposite sides are the same. Which side is going to be my right? The one with the 10. So 2 and 2, because they're exactly the same. All I have left is my front and my back. Yes? So I know that these are going to be the same. Does that make sense? Okay, so I have 1, 2, and 3. Let's talk about our ones. Our base and our top. What is the length of our base? 12. If this is 12, that means this one is 12 because they are the same. Yes? And what is the width of my base? 15, because 15 is for all these lines. Make sense? So what is the area? Yes? Say that again. 180 feet squared. But that's just my base. What do I know? I have 2 of them. So I'm going to multiply and get 360 feet squared. Make sense? All right. Second one. My left and my right. What is the width of my left?
15.
Yeah. 10. And what is the length? You say it. You said it a minute ago.
15.
15. Because if this is 10, I know this is 10. They're exactly the same. And again, all of these lines are 15. Make sense? So I get 150 feet squared. But there are 2 of them, so it is 300 feet squared. Make sense? Then I have the last 2, our rectangles number 3. What is the width of rectangle number 3? 10. And what is the length? 12. So I get 120 feet squared. But I have 2 of them, so that is 240 feet squared. Do I know my total surface area yet? No. What do I need to do? Add them together. So I have 240 plus 300 plus 360, and I get 0, 0, 9. 900 feet squared. Make sense? All right, we're going to skip number 8, and we're going to move on to the next page because it is very important.
Time?
And I'm not trying to go to the bathroom.
Oops, sorry. We're going to page 103. We're going to add a couple notes, but we did have a couple definitions that we need to throw in here first. So like highlighters. Your first definition is a pyramid. A pyramid is a polyhedron with one base and the same number of triangular faces as there are sides of the base. The vertex of the pyramid is the point at which all of the triangular faces intersect.
Everybody should be marking in their
You also have and I'm going to change the colors to make it easier for you guys. Sorry. We also have another definition called a slant height. The slant height of a pyramid is the distance, and it is a pyramid, the distance measured along a triangular face from the vertex of the pyramid to the midpoint of an edge of the base. So what we're talking about, the slant height would be this line right here. So this is the slant height. We figure this one out because that gives us the height of the triangles that are on the side. In a pyramid, we're going to have how many sides my basis has. That's how many triangles I'm going to have around it. Okay? The vertex is this one point all the way at the top. That is your vertex. The slant height is that one that's in purple. The vertex is the one point that's right at top. These become very important as we start talking about naming these types of figures. So, I'm going to label this naming 3D figures. There's really only 2 steps to it. The first step, and this is actually the most critical one, is identify the base. Part of that is going to come from understanding if I'm looking at a pyramid or a prism. The way you know that is what's on the side. The biggest thing to look at, does it have a vertex? If it has a vertex, it's a pyramid. If it doesn't have a vertex, it's going to be a prism. Okay? Why is that important? Because it can get very tricky because you can have prisms that have triangles. And normally when you think of triangles, when you think of pyramids, you think of triangles. But this shape right here, you see, has a triangle, yes? But it actually has 2 of them. There is no vertex there. So what would we call that shape? Good, sir. Good. And step 2 is we either say pyramid or prism. In this case, this would be a triangular prism. Why? Because my sides are all rectangles. If you look at those three sides, those are all rectangles. Sides of a prism are rectangle, sides of a triangle, of a pyramid are triangles. Our second one, again, I look at my base shape. What shape is that? It has 5 sides. Pentagon. So this would be a pentagon prism. As my sides, again, are all rectangles all the way around it.
Guys, all these notes he's making on the board.
How about this one? How many sides do I have? 8. So that makes it a octagon prism because my sides are all rectangles. So the pyramid or prism comes from the side shape. Is it a pyramid or a triangle or a rectangle? The first part of the name, though, comes from your base shapes. You have to identify your base. So the one that we've been drawing all over, what would you call this figure? The purple one.
Pyramid prism?
Identify the base. Square. Is it a pyramid or a prism? Starting to see it? So that's going to be a big part of your homework, is being able to name these different shapes, guys. Okay? Yes, ma'am? Okay. Questions on how we name them? Okay, so we're going to go to page 104. One of the big ones on these, if they give you the net, mentally fold it together and see what you get. A huge piece of this is you can kind of count and see what the majority is. So this one I've got 4 triangles, right? You think that's going to be a pyramid or a prism?
No,
Pyramid. So I look at my base shape, which is a square pyramid. This one gets a little trickier, but I have 3 different, in this case it almost looks like cubes. So when I fold them all up, I'm going to have 2 bases, making that a triangle prism. Yeah. Square. Good point. You actually got me once. You should probably write this thing
So
down.
many more times than that.
Now these ones, if I'm going to draw the net, I just kind of do the opposite. I'll give you a hint. If you're going to do a net on a prism, I would start with the rectangles. I'm going to do the base of do a net of a pyramid. I would start with the base shape. Okay? So prism, start with rectangles. In other words, the sides. And for a pyramid, start with the base. So whatever the base figure is. So just a quick hint, the easier way to draw nets for pyramids and prisms. So it does look a little different. There are other ways to do it. That's just the easy way. Good, unfortunately we didn't get to homework, so let's go ahead and turn to page 115. Notice I didn't say to put anything away.
Or to pack.
Or to
tear
pack.
out, or anything else.
So here's your hints. Describe how to determine the surface area of a solid in your own words. Okay, so you should come something to this fact. I need to figure out all the surfaces and put the areas together. Name the solid figure formed by each net. In other words, that's when we just went through the naming conventions. Figure out what's the bases, what's the sides. Draw a net that will form each solid figure. I just gave you hints on how to do it for a prism in A pyramid in B. So that should be a big hint for you. Going to page 116. Calculate the surface area of the cube. That's cube. That is key because it tells me every measurement is 1.5. So hint, find one of them, do it times 6. You don't have to do it 6 times. Calculate the surface area of a rectangular prism with a length of 9 1/3, a width of 4 3/4, height of 60. Are you okay if I give them the formula? Guys, I'll make this easy for you. To find surface area of a rectangular prism, it's 2 length width plus 2 length height plus 2 width height. I've got 2 of each side, and I'm just multiplying it. So all I gotta do, they gave you LW8, put it in the formula. Exactly what we did. Okay, pyramid has a square base and incongruent triangular faces. Calculate the surface area of the pyramid. Do not forget, the formula for a triangle is 1/2 the base times the height. They've given you the slant height. That's what you're going to need. You're looking at the that one. And this one, triangular prism. Triangular prism. Easy way to do that, calculate the area of the base, which they actually gave you the height of the base for the rectangle, for the triangle. So it gave you the height of that base. Realize this is a rectangle here. There are going to be 2 of those because the 2 sides are the same. And then you have an additional one on this one. So that one's going to be a little more difficult. You may want to draw the net on that one just because your dimensions are different. Questions on your homework? Okay, remember, do 18 Matthew workspaces by Friday. By Thursday, because we'll be putting it in on Friday. And all of your homework is due by Thursday. See you, lunch. You haven't done yet.